Okay, so today we're starting section 3 of chapter 13, and today we're talking about proportional relationships, and we'll be graphing them. So there's going to be something in common with all of our proportional relationships. But before we get into that, let's just go over some of our terms and definitions here. All right, there's always a clear connection. That clear connection is our slope, or our rate. There's always some kind of clear connection between X and Y in a proportional relationship. The rate of change is constant. So it's not like, going back to our frozen yogurt example. Well, if you buy 1 ounce, it's $4, but if you buy 2 ounces, it's $3, and then if you buy 3 ounces, it's $8. Okay? That's not how it works. There's going to be a constant rate of change, and it will be predictable. All right, so the equation y equals mx. So that's really similar to slope-intercept. It just doesn't have the b part at the end, and we'll talk about y in just a minute. The constant of the proportionality, all right, that's just a fancy word for the rate. The constant value that makes x and y proportionate. All right, that's my m value. What am I doing to x? Am I multiplying it by 2? Am I dividing it by 4? What am I doing to my x value to give me my y value? All right, so what does it look like in an example, and what would it look like on a graph? So we have y equals 4x. In your 13.1 homework, do you guys remember seeing a problem like this, and you're doing the table and you're like, okay, so all I have to do is plug in for x, and that was it. You didn't have to add anything. You didn't have to subtract anything. So if there's no number behind the 4x, now this is important, okay? That means that there's a 0 back here. It's like plus 0.
Like the input-output table?
Yeah, you don't even, actually we will do an input-output table. We won't have to after the next lesson, but we are going to today. All right, so that's like a plus 0. There's nothing there. Do you remember when we talked about, and it was only in this class, in first hour, but we talked about like going to an amusement park? If there's an entrance fee, like everybody pays the entrance fee, and then you pay per ride after that. Okay, so the plus 0 is like a starting amount, okay? That's going to be important for you to remember as we kind of get more into equations and what equations tell us. All right, so just for this example, we're going to set up our XY table. All right, so do I have a whole number or a fraction connected to X?
Whole number.
What is my constant of proportionality? It's a whole number, okay, my m value. So if it's a whole number, what 3 numbers do I use? -1, 0, and 1. I use -1, 0, and 1. All right, so now I'm just going to plug them in for x. Remember, if there's nothing behind 4x, that means that there's a 0 there. All right, so what's 4 times -1? -4. All right, I want you to fill in the rest of the table. Go ahead and plug them in and fill in the rest of the table. What's 4 times 0? 0. And what's 4 times 1? 4 times 1 is 4. Very good. All right, so now let's put these 3 ordered pairs on the graph. We have -1, -4. That's a little off. -1, -4, 0, 0, and 1, 4. Now, if we do this correctly, it should form a straight line, and I want you to use the edge of your badges just to help you do a really nice straight line right through these 3 points. All right, let's see if I can do it. That's a little off. Closer. Okay, straight line through the 3 points. Okay, and now let's talk about proportional relationships. A proportional relationship will always pass through the origin. The origin is 0, 0. So do you see how this line is passing through, right through the middle? You see that? That's significant. All right, here's why. That means when my x value is 0, what did x stand for in the original problem? What did x stand for? Ounces of frozen yogurt. Do you see that? I just highlighted it in the original. What did y stand for? Dollars. So here's what this problem is telling me. If I buy no frozen yogurt, meaning if my x value is 0, how much money am I going to pay? $0. Okay? So when my x value is 0, so is my y value. I don't pay money just to walk into the door of a frozen yogurt place. Right? Now, none of us would ever go into a frozen yogurt place and get a bunch of samples and then not buy anything, would we? Right? Okay. Yeah, don't do that. All right. So at least buy something. So what is the rate telling me? Look at this number right here. This number in front of the X. This rate is telling me how much money I would pay per ounce of yogurt. So look at the 4-1. Okay. And we'll talk in a minute about the negative, because actually we shouldn't have put the negative in there. We'll talk about that in a minute. Look at the 1-4. All right. So now, what did X stand for? Ounces of frozen yogurt. So if I buy 1 ounce of frozen yogurt, how much money am I going to pay? $4. This is a real expensive frozen yogurt place. That's not, like, they're probably going to go out of business. Why? All right, so our standard set of values include a negative. Why should we have actually left the negative off?
You don't start negative yogurt.
Can you go up to the counter and say, I would like to buy -1 ounces of yogurt, please?
You give them yogurt, they give you
No, okay? Yeah, give me a refund. No, give me a refund for something I didn't buy. So you can't have a negative X value, all right? So just keep that in mind. Technically, you would only want 0 and 1 and 2 to be your input values if there's a scenario here like we see here. All right, is that making a little bit more sense? Yeah. Why proportional relationships tell me when my X value is 0, so is my Y value. All right, so what if the frozen yogurt is represented by y equals 0.75x? How would you interpret that slope? So on the last problem, it was a 4, and I said that the yogurt cost $4, I would pay $4 for 1 ounce of yogurt. So what do you think the 0.75 is telling me? Maybe this is a different store. Yes, this one is 75 cents.
So you replace the 4 with
Yes. Yeah, so this rate is different. If I were to plug in a 1 for X, meaning 1 ounce of yogurt, that means that I'm paying 75 cents for 1 ounce of yogurt. I want you to answer this. For 1 ounce of yogurt. So if the yogurt is exactly the same, it's made exactly the same, which store are you going to go to?
the expensive one.
75 cents.
No.
75 cents, you get more for your money, you get more bang for your buck. Right? This one's only 75 cents per ounce of yogurt. Could you use that to kind of scale it? What if you wanted 2 ounces of yogurt?
Maybe $1.50.
Be $1.50. $1.50. You just multiply it by 2. What if you wanted 4 ounces of yogurt? What could you do?
$3.
Plug it in, multiply by 0.75, $3.
I'd rather go pay 12.
Oh yeah.
Because that's gas money.
Okay.
nowadays.
All right, the weight of an object. So what we're starting to do in this lesson is we're starting to attach a category to our X and Y values. So it says the weight, that's my Y, of an object on Titan. So what does Y stand for? The weight of an object on Titan. What's Titan? It's one of Saturn's moons. Okay? is proportional. So there's my word. It's proportionate. So there's a constant rate between the two values to the weight. What does X stand for? Of an object on Earth. So Y stands for Titan. X stands for Earth. The weight of an object on Titan is proportionate to the weight of an object on Earth. An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. So I'm going to start off with my equation. My equation for a proportionate relationship is Y equals mx. This part you're going to have to know. That's all the information they're going to give you. You're going to have to know, okay, if it's proportionate, then that means Y equals mx. All right? So now, what did Y stand for? This is where it's important to understand what X and Y stand for. What did Y stand for in the problem? Object on Titan. Okay? So you have to decide which number is the value for Titan. It says an object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. Which number would you plug in for Y?
50.
Why would you say 15?
Because something that weighs 100.
Because that's the weight on Titan. Do you see that? Okay. So 15 gets plugged in for Y because I was told that Y stands for the weight on Titan. Equals, I don't know M. I don't know the rate yet. All right, so I'm going to say M times, what is the weight on Earth? 105. Well, is there a better way that I could write a number times a variable? Normally, I write it in reverse. So you can just go ahead and do that. All right, you know that that's the same thing as saying 105M. Okay, 105M. How would you solve for M? How would you solve for M? Divide it by, be careful, whatever's connected to your variable. All right, so divide both sides by 105. So now I have a fraction. Okay, now you are allowed to use your calculators, but your calculators don't have a fraction option. What I would do is I would see if 15 goes into 105. Okay, so does 105 divide by 15? Okay, how many times? 7. So if I reduce this by 7, I get M equals 1 over 7. Okay, so I just reduced top and bottom by 15 because 15 goes into 105. 7 times. So M equals 1/7. All right, so this is the most important part of this example. You're going to take 1/7 and you're going to plug it in for X. All right. You have now found the rate. You have now found the constant of the proportionality. What did Y stand for? The weight on Titan. What does X stand for? The weight on Earth. So here's what it's telling me. The weight on Titan, what I can do is I can take 1/7 of the weight on Earth. Okay? So whatever my weight on Earth is, I'm going to divide it by 7, and that gives me the weight on Titan. That gives me the rate. Okay? So now I'm just going to start throwing out numbers to you. What if the weight on Earth was 49 pounds? It would be 7 pounds on Titan. What if the weight on Earth was 56 pounds? It would be 8 pounds on Titan. Do you see what I'm doing there? So you found the rate, and now you can apply it to anything. Now I'm going to flip it around. What if the weight on Titan was 3 pounds? It would be 21 on Earth. You multiply it by 7. Do you see how it can go both ways? So what if the weight on Titan was 10 pounds? It would be 70 pounds on Earth. All right, so this rate can go both ways. So now I want you to answer this question. How much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? What I want you to do is plug in that 3.5 for y, okay? Or, you might be able to do it mental math kind of like we were just doing. But I'm going to plug it into the equation and solve and show you what I'm doing. Okay, so here's what it looks like. 3.5 pounds on Titan, that gets plugged in for y. So I get 3.5 equals 1/7 x. Well, how do I solve for x? What do I need to do to get rid of 1/7? How do I solve for it? I need to flip it and multiply, right? So what I'm saying is I need to multiply this number by 7. 7 times 3.5 is what? What'd you guys get? So x equals, or my weight on Earth, is 24.5 pounds. 24.5 pounds. All right. So again, it's just solving for, it said how much would it weigh on Earth? So that means I didn't know my x value. So I would solve for x. What if I asked you to express this number in ounces? 24 pounds and how many ounces? Does anybody know how many ounces is in half of a pound?
6, 8, 12.
Yes, half. So there are 16 ounces in 1 pound. So that means there's 8 ounces in half of a pound. So this is equivalent to 24 pounds, 8 ounces. You don't have to do that on your test, but it's a good reminder. All right, how are we doing, guys? Okay, so if all you walk away from with this lesson is just a little bit of a better understanding of your slope, then we are making progress, okay? You're not going to walk away from this lesson thinking, I'm ready to ace my test tomorrow, all right? These are tough concepts. No, I'm saying we're not ready for the test. Your test isn't until after spring break, okay? But we're making progress on understanding what the slope is telling us in an equation. Okay, so the distance y in meters, okay? So what does y stand for? Meters that a 4-person ski lift travels, okay? So that's what my y stands for. My y stands for distance. Travels in x, what does x stand for? Seconds. All right, so look at this equation. X stands for seconds, and then y stands for distance in meters. So it's really important that we understand what x and y stand for so we can answer the question. The graph shows the distance that a 2-person ski lift travels. So over here, this is the distance that a 2-person ski lift travels. All right, I want to know which one has the faster rate, all right, per second. So the 4-person ski lift is y equals 2x, 2.5x. What I don't know is what the 2-person lift travels. I need to find my slope from a graph. Does anybody remember from last week when we learned slope, Macy? Okay, from last week when we learned slope, rise over run. Do you guys remember that? So let's count our rise. 1, 2, 3, 4. And then what's my run? 1, 2, 3, 4. So y equals 4 over 4x. Well, what's 4 over 4 reduced to? 1. So y equals 1x. All right, so what is this telling me about the speed? All right, so what if I plugged in 1 for x? X is seconds, right? So how far does the 2-person ski lift travel? 1 meter per second. That's what the rate is telling me. How fast does the 4-person ski lift travel? 2.5 meters per second. So which one is faster? The 4-person. So what we're learning in this example is how to compare our rate. Our rate tells us the connection between X and Y. So could you plug in, let's say, 4 seconds here and figure out how many meters it travels? Yeah, just do 2.5 times 4. Can I just tell you that this is unrealistic? A meter, there's 3 feet in a meter. That ski lift is like jet speed, not quite, but let's just say, I hope that I'm buckled in tight if I'm on this ski lift. All right, I don't think it's very realistic. So really just understanding how to read your slope, that's a big part of what you learned today. All right, so that's going to be everything we'll cover for
Does he have
today.
shoes in that